Okay, so we're talking about chemical equations. We've been talking about chemical formulas. So all last week, we practiced looking at just one formula with different elements chemically bonded together. We talked about subscripts representing the number of atoms of a certain element, and we talked about coefficients, which represent the number of molecules. Your coefficient is the big number in the front, and your subscript is the little number that's behind the element it represents. Okay? So chemical equations, they are several of these formulas put together. So we're adding these compounds together to create something new. It's how we represent chemical reactions. So the common household baking soda and vinegar, those each have a chemical formula, and when you add them together, a chemical reaction occurs, and we use an equation to illustrate that. Okay, so your equations are basically the recipes for a chemical reaction. Okay, there are 5 parts. We have reactants, which is the left side of the equation, and they're going to be elements or compounds at the beginning. They're what you start with. Then we also have products, which are on the right side of the chemical equation, and they are what is produced. They are the result of the chemical reaction. They are the new elements or compounds that have been formed by mixing the reactants. The yields is the arrow. So when you see a chemical equation, there is an arrow, and it basically means equals. So when we add our reactants, it yields our products, or it creates our products. Okay, and then a review of coefficients and subscripts are listed. So here is an example of a chemical equation. So as you can see, on the left side, we have our reactants, and on the right side, we have our products. And this is the yield sign. So what this is saying is magnesium plus oxygen yields magnesium oxide. Okay, that's a new compound. This is called a synthesis reaction. We have 2 atoms of 2 molecules of magnesium plus 2 atoms of oxygen yields 2 molecules of magnesium oxide. So if you split this in chunks, you're very familiar with these, but we're going to put it all together now. A common chemical reaction is photosynthesis. So plants take in the carbon dioxide that is a byproduct from humans. So we inhale oxygen and exhale CO2. The plants use that CO2 and they use water. Sunlight provides an energy to initiate the reaction. It's that thermal energy from the sun that causes the CO2 and the water to react and create oxygen and glucose, which is a sugar. So the sugar is what plants use for their food, and their byproduct is oxygen, which is what we need to survive. So without photosynthesis, we as a human species would not be able to have oxygen. So for chemical equations, what you're expected to do in 8th grade is calculate the number of atoms in this equation. So this first example says how many oxygen atoms are on the product side. So your first step is going to identify which side of the equation is the product or the result. The right side of the yield sign. So on this side, it's asking us how many oxygen atoms. So I see 6 oxygen atoms here in this compound, and then 6 times 2, that's 12 total in this one. So 12 plus 6 is 18. So there's 18 total oxygen atoms on this entire side. Okay? So it said the product side, so you have to add the oxygen atoms from here and from here. And then it wants to ask how many elements are in this chemical formula. I don't like that because it didn't specify which one, because this is a chemical formula, this is a chemical formula. The entire thing is a chemical equation. So I'm going to tell you the number of elements in the entire equation. We have carbon and oxygen and hydrogen. So there's only 3 total elements in this equation, C, H, and O. The final question, and I'm going to pause to let you answer, is how many molecules of water are on the reactant side? What determines the number of molecules or groups? 6 molecules of water. So you have to use the coefficient to identify the number of molecules, and then we know H2O is water. So this is the definition of the law of conservation of mass. And really the most important part of that is that mass can't be created or destroyed. So you see a lot of words right here, but it's really, really important. Mass cannot be created or destroyed. And so if you look at this picture, what it's saying is this is to model our reactant side. And you count all the dots that we have on this side. So if you look at the blue dots, there's 1, 2, 3, 4. Look on the product side, there's 4 blue dots. And around each blue dot is 3 white dots. So that's 3, 6, 9, 12. 2, 4, 6, 8, 10, 12. What it's saying is that the number of atoms on your reactant side and the number of atoms on the product side will always be equal. You may have new compounds and new substances that have been formed, but the number of atoms will always be equal. So I'm going to go back up to this photosynthesis equation and show you. On the reactant side, I have 6 carbon atoms. This molecule, this coefficient tells me I have 6 carbon atoms. If I look on my product side, I have 6 carbon atoms due to that subscript. Okay? I have 2 times 6, 12 plus 6, 18 oxygen atoms on the reactant side. And we already calculated that there are 18 oxygen atoms on the product side. This coefficient of 6 times 2 for hydrogen tells me that I have 12 hydrogen atoms on the reactant side. If you look on your product side, there are 12 atoms of hydrogen as well. So this is a balanced equation. This equation follows the law of conservation of mass. The amount of atoms on my reactant side, the amount of atoms I started with, is equal to the number of atoms that I ended with. Okay? And that's really what we're going to be practicing with chemical equations, is we're going to demonstrate the law of conservation of mass, that it cannot be created or destroyed. Okay? No atoms are destroyed and no new atoms are produced during a chemical reaction. The atoms are simply rearranged. Chemical bonds between atoms are broken and new ones form. The atoms simply reconnect in new ways. So nothing is created or destroyed, they're just rearranged. Okay? Here is another example. We have 2 atoms of hydrogen plus 2 atoms of hydrogen plus 2 atoms of oxygen, and they're rearranged to make H2O. We still have 2 big old red dots, and we have 4 little white dots. In this equation, there are equal numbers of hydrogen atoms and equal number of oxygen atoms on both sides of this equation. This equation is incorrect. Do you see why it's incorrect though? H2, there's 2 atoms of oxygen on the reactant side, but there's only 1 atom of oxygen on the product side. That can't be accurate. There has to be 2 atoms of oxygen on the product side as well. So this chemical equation right here is incorrect. So what they did to balance that incorrect equation is they added a coefficient. We can change coefficients. We can never, ever change subscripts. So the little number will never change. We can't add or take away from that, but we can always add a coefficient, which is what they did here. So there's 4 atoms of hydrogen, 4 atoms of hydrogen. There's 2 atoms of oxygen, and there's 2 atoms of oxygen. When we look at this chemical equation here, I need you guys to identify the number of magnesium atoms on the reactant side. How many atoms of magnesium are on the reactant side? Tell me how many atoms of magnesium are on the product side. We identified that there were 2 on my reactant side, but how many are on my product side? Go over that again. We identified that there are 2 magnesium atoms on my reactant side, and we know that when we distribute our coefficient, when we multiply our coefficient to each element, that it tells me I have 2 atoms of magnesium and 2 atoms of oxygen. So 2 atoms of magnesium on both sides and 2 atoms of oxygen on both sides. This equation demonstrates the law of conservation of mass. We started with 2 atoms of each element and we ended with 2 atoms of each element.